Welcome to another unit on how to work with the formulary in Statistics 2. In this part we're going to talk about the different versions of comparing means, so on how to test for specific parameters. Well, I said comparing means because the first three parts are the more important parts. That's how we can check whether the arithmetic mean of a sample deviates significantly from a test value, where the test value in these cases always is the mu0. We always want to test, is this arithmetic mean different from this testing value? Or rather, based on the arithmetic mean, is the true mean equal or different to the testing value? We have, as an addition, and that's why it's only called testing parameters, down here, also the version where we can test whether the real variance is equal to given value or different from it. And all of these versions, especially regarding the first three parts, first off, we need to decide which version we use. The main difference, do we know anything about the variance or the standard deviation? If we know the variance or standard deviation, we can use the Gauss test as in the first version here. If we do not know this, usually we go with the t-test version. We can, however, also use the Gauss test version if our sample size is large enough. If we have a sample size of 50 or above. In either case, if you look closely, the test statistic always looks, I wouldn't say the same, but pretty similar, because independent of whether you do what's in the first, second, or third row, it's the same thing. Before I go into this, the first row in each of the three cases is always the two-sided version. Meaning our mean is different or the same as regard to the testing value. The second and third row, it's always a one-sided test. So in this case, I want to show that the true mean is larger than the testing value. Here I want to show that the true mean is smaller than the testing value. And the same thing goes for this Gauss test and this t-test version as well. Well, as I said, test statistic is always the same. It's always arithmetic mean minus testing value divided by standard deviation or sample standard deviation times the square root of the number of observations. So same thing here in all cases. The only important aspect here is with the test. However, we see a similar structure here as well. So in the first two cases, if our testing value is larger, or in the first case is the absolute thereof is larger than the reference value we have to look up, the right side always being the reference value, you have to look up in the tables at the end of the formulary. If it's larger, you can reject H0 only in this situation. The one where we want to test whether something is larger, the testing value, the test statistic actually needs to be smaller. However, in this case, usually we get a negative test statistic and a negative reference statistic. So in this case, would also hold that more or less, absolutely speaking, the test statistic would be larger. However, in this case, you need to consider that this is slightly different. Okay, so much, so good on the part on the comparing of means context. However, if we look here, even for the variance test, the test statistic is exactly the same as before. And again, we only have here 3 cases for the test, while the last 2 look similar to what we had before. In the first one, we actually have 2 possibilities. So here we need to check 2 conditions before we can actually reject H0. Because if this holds true or this holds true, in either of the 2 cases, we can reject H0. So there's actually 2 possibilities for us to reject H0 if we run a test for the variance. Well, that's then everything there is on these parameter tests. So I say goodbye and see you next time.